Okay, you guys, we're live. Sorry that we didn't get this done in class, but I will record it, and then I can take my time. I'll go slowly, and you guys can follow along. Now, where's my pens and pencils? Here they are. Okay, so number one, we want to rewrite it in standard form. And if we want it in standard form, then the first thing we do is rewrite it with the biggest exponent first. So I'm going to go part A, we're going to go f of x is equal to a negative x cubed plus a 2x minus 1. So always biggest exponent all the way down. Then the next thing I'm going to do after I do that is the degree. Well, the degree is the biggest exponent, so my degree is equal to 3. My leading coefficient, there's an invisible 1 right here that we normally don't write, but it's always the first number, leading coefficient. So my leading coefficient is the number in the front after you rewrite it, which is negative 1. Here, I'll circle it so it's blue and blue. Okay, there you go. Local mins, local max, and find values where it's increasing, decreasing. So I want to graph this one, and I want to put it on graph paper so I can see it. So I'm going to put it in my Desmos, and I'll try and make the test. You guys can use Desmos right off the bat, and then I'll take your phones away, and we'll do the rest test without Desmos. Okay, so here we go, Desmos. Let me graph this thing. Get rid of that. Rid of that. And so I'm going to go y equals a negative x to the third power plus 2x subtract 1, and I'm going to go look at it like this. Okay, so try and put this on my graph paper. It'll be handy if I can actually see it. So I'm going to take my x and y axis, and I can just tap on my Desmos to get my points. So there's one of the zeros. But anyway, what I want is this 0.8 and about 0.9. So it's really pretty small. So it's right about there. And this is a local, like Michael said. This is a local max. And it's about a 0.8 comma at about a 0.1. Yeah, we'll round it to 0.1. So it's not very tall at all. There's my local max. So my local max is at about 0.8 comma 0.1. My local min, I'll tap on that, is about a negative 0.8 and a negative about 2, pretty close to right there. So we get about a negative 0.8 and a negative 2, okay? I have zeros. If I need my zeros, it has a 0 at about negative 1.6, about there. Has his 2 zeros here at 0, at 1, and about 0.6, okay? Let me draw it in. So the graph looks something like this. Goes through at negative 1, goes up like this, and down like that, okay? So if you really blow it up, it's easier to see, okay? So max, local min, local minimum. Local minimums at about negative 0.8, comma, negative 2, about, okay? Top of the hill, max, local max. Bottom of the hill, min, local min, okay? Now, if we want to find out where it's increasing, decreasing, it's all about the x values, okay? My x values. One way to do it, oops, sorry, I was off the screen, my bad, is to just look at the x-axis, okay? So let me go ahead and relook at this x-axis. Just one way to do it. I do know you got a max right here at 0.8. You got a min right here at negative 0.8, okay? The graph goes down here from 0.8 on. The graph is going downhill from negative infinity to 0.8, And right in between this tiny little place in here, it goes up, okay? This tiny little place is going up. So it's increasing. Oh, let's do decreasing first. It's decreasing from my negative infinity to negative 0.8. And it's also decreasing, going down from 0.8 to infinity, and from a 0.8 to positive infinity, okay? Both. It's going down to right here, and then it goes down from 0.8 down, okay? It goes down to 0.8, negative 0.8, and it goes down from 0.8 on. It goes up just in the small region up here, so it's increasing from negative 0.8 to a positive 0.8, okay? All right, increasing, decreasing. All right, let's move on. Hopefully that makes a little bit of sense. Let's take a look at number 2. Okay, so number 2 really isn't that bad either. To do number 2, I do know that from here to here is 2x plus 3. And from here to here is a 2x. So the entire length of this is a 4x plus 3. Going down, I know from here to here is x, and then coming down the rest of the way is a 2x plus 1. So the entire length here has to be a 3x plus 1. So if I want the area and perimeter, let's do perimeter first. I'm just going to add up all the way around. Perimeter, let's see, I'm going to start here. I'm going to add. So I'm going to go 2x, 4, 5, 6, 7x, 8, 9, 10, 11, 12, 13, 14. So I got 14x. I'm just adding all the x's all the way around. And then if I add the numbers, I got 3, plus 1 is 4, 7, 8. So there's my perimeter in terms of x's. Area. To get the area, we're going to have to break it up into 2 different rectangles. I think that I would do a rectangle area 1 and then area 2. We'll go area 1, length times width. Remember, area is length times width. So area 1 is going to be just my 2x plus 3 times my width, which is my 3x plus 1. Added to area 2, which is this small little rectangle, which is x times my 2x. Now, I would like you to simplify this. So let me get out my other paper that I've been writing on so I can simplify this. Okay, and to do number 2, I'm just going to simplify what I have for area. I'm just going to get a 6x squared plus 2x plus 9x plus 3, and then plus 2x squared, because I multiplied x times 2x. Well, if I combine my x squareds, my area would be a 8x squared. Combine my x terms, plus 11x plus 3. That's the answer I'd really like to see. I guess I would take that answer, but this answer is more simplified. Okay, number 3. All right, in this piece of paper, I'm going to have to do a big multiplication. Now, first of all, before you even start, there's no plus sign. It's just multiply, okay? All right, so I'm going to multiply. So we're going to go x squared times x squared, x times x, x times 4. So I'm going to do that first. So I'm going to get an x to the 4th minus an x cubed minus a 4x squared. Okay. Then I'm going to go my 4 times x squared, my 4 times my negative x, my 4 times my 4, and I'll get a 4x cubed. I'm going to put that there. I like to line them up. Makes it easier for me. I'll get a negative 4x squared. I'll put that right there. 4x times a negative x. And then I'll get up minus 16x, and I'll put that there. And then finally, I still need to multiply 6 times x squared, 6 times negative x, and 6 times negative 4. When I do that, I'll get a negative 6x squared. I'll put that there. I'll get a positive 6x because a negative times a negative. And I'll get a positive 24, negative times a negative. Now, I do this on purpose. See, I have them lined up. So when I add, I can add x squares with x squared. So I have an x to the fourth. I'll have a positive 3x cubed minus 14 x squared minus 10x plus 24. And that is completely simplified and multiplied through. Okay? Okay, 14. We are going to have subtract. Okay, so before I do a lot of subtraction, I like to add. I like to make an addition problem, so I bring the negative through, making a negative 43x squared minus 16x plus 4. So that when I add, I'm adding like terms, okay? I like to add. I make mistakes when I subtract. So now it's not too bad. I've got a 15x squared with a negative 43x squared. What's that? I guess calculate, what is that, 28 or something like that? Probably. No, maybe. Yeah, well, hold on. Negative 43 plus 15. Yeah, I should listen to myself. Negative 48. Negative 20. Negative 28x squared. Let's combine my x's. So negative 18x. And then I think this is the only term. I've got the only constant term. And so I've got a positive 4. Okay, that's what I want. Okay, number 5. It's going to take Pascal's triangle. Here we go. All right, number 5. So I'm going to use the fourth row of Pascal's triangle, which is 1, 4, 6, 4, 1. I like to do A's and B's. I just do A4, A3, A2, A1, and OA's, right? 4, 3, 2, 1, none, and then the B's. B4, because we're doing the fourth row. That's what I'm doing. B4, B3, B2, B1, and no B's. Except for this problem really doesn't have anything to do with A's and B's, so we're going to let 2x equal my A, and we're going to let my 3 be my B, and I'm going to substitute those values in for A and B. So we'll rewrite this as a 1, not what A is, not A, but what A equals, which is a 2x to the fourth, plus 4. Not A, but what A is equal to, which is a 2x quantity cubed, times B, not B, but what B is equal to, which is a 3, plus 6. Not A, but what A is equal to, which is a 2x squared, times B, or B squared. B is 3, 3 squared, plus 4 times A. What is A equal to? 2x times B cubed, but not B, but 3 cubed, plus 1 times B. That's not a 16, that's a 1, and that's a B. So 1 times B. B is 3, or 3 to the fourth power. Okay, let's see if I can simplify this, okay? All right, this is 2 to the fourth is 16, times 1 is 16x to the fourth, okay? 2 to the fourth is 16x to the fourth, plus 4 times 2 to the third power is 8x cubed times 3, okay? 2 to the third power is 8x cubed, plus 6 times 4x squared, because 2 squared is 4, and then times 9, because 3 squared is 9, plus 4 times a 2x times a 3 cubed is 27, plus 1 times 3 times 3 times 3 is 81 times 3. So 3 to the fourth power is 81. Now, let's finish this up. Okay, calculator, got a lot of big numbers. So 16x to the fourth plus, okay, 4 times 8 times 3, I don't know, let's figure it out. Well, I probably could do it. It's 96, but let's say 4 times 8 times 3 is 96 x cubed. Let's see, 6 times 4 is 24 times 9, so we'll go just 6 times 4 times 9 is 216 x squared, and then 4 times 2 times 27, 4 times 2 times 27 is 216x, and 1 times 81 is 81. There it is. It's a lot of work, but we've done this before, okay? So there it is. All right, moving on. Let's get this done. Okay, now factor. Well, all right. Some of these I can just do pretty quickly. On the first one, on number 8, they have a common x. So I'll take out the x, because x goes into all three. So if I take out an x, it makes it simpler. X squared minus 2x minus 8. And then I have a trinomial. And I'll leave the x, but I have a trinomial, so I'm going to go parentheses, parentheses, parentheses. X times x makes x squared. And I'm going to use a negative 4 and a positive 2 to make the negative 2. Negative 4, positive 2. That is completely factored. Okay, number 9. Well, the formula is on the board. So I'm going to rewrite it for us so you can see it. But the formula I want is this a cubed plus b cubed, which is a plus b, a squared plus ab, nope, it's minus ab plus b squared, but those are on the board. So how do I know that? Well, this is the same thing as a 4x cubed. 4 times 4 times 4 is 64, plus a 5 cubed, because 5 times 5 times 5 is 125. So my a is going to be 4x. And my b is going to be my 5. So I'm just going to plug these into my formula here. So I'm going to go a plus b, or 4x plus 5. A squared, or 4x squared, which is a 16x squared, minus ab. So I multiply these two. Minus 20x plus b squared, or 5 squared, is a 25. And that is factored. Okay, done. Let me write that down here. So it is a 4x plus 5, 16x squared minus a 20x plus 25. Okay, there we go. All right, 10. Well, let's see if we can make it easier. So if I take out a 3 and an x, it will make the problem easier. Hold on just a second. Don't want this to get in the way. So then if I take out a common 3x, I'd have an x squared minus 9. Well, that x squared minus 9 can be factored again. I know that if I go x times x plus 3 minus 3, that will make my negative 9, and my x squared. Middle term of 0 is there. 11. Okay, we're getting there. 11 I'm going to do by grouping. There's 4 terms. When I see 4 terms, I like to do grouping. Put these two together, these two together. So what I see is a common x squared, and that's all on the first two. All they have in common is just an x squared. X squared is in both. Then if I pulled out a common factor out an x squared, I'd have a 2x plus 3 left over. Now these two terms don't have anything in common except for the negative. So we take out a negative 1. You have to have a number. You have to have a number here. So take out a negative 1, I have a 2x plus 3. Okay, now looking at both of these terms, they do have something in common. They both have a 2x plus 3. So we'll common factor out the 2x plus 3, and what I have left is my x squared minus 1. Valeria asked, is that enough? If you can see more, I want you to go more. And I can see that I can factor that x squared minus 1 one more time. So, I'm running out of room, scoot that over here. So I still have a 2x plus 3, but x squared minus 1 can be x plus 1, x minus 1. X times x makes x squared. Positive 1, negative 1 makes negative 1. So this is completely factored. Okay, number 13, divide. I'm going to use synthetic division. I'm going to use my scratch paper so I have room. So we put 13 right here on my scratch paper. All right, so synthetic division, right? Let's go upside down. And I am missing a term. There is no x squared term. 4, 3, oh, there's no x squared term, so this is 0x. I got to be careful of that. I've got x to the 4th, 3rd, 2, 1, none. Okay, so let's put the coefficients in. X's are invisible, so we'll go 2, negative 5, 0, 4, negative 4. Put my add line in here. Here's my add line. And I put my remainder under the negative 4. There's my remainder. Okay. I'm going to divide by the opposite of this number. Okay, which I'm going to put a positive 1 right here. Opposite, positive 1, okay? Now, we're ready to divide. Do our synthetic division, that is. Step 1, bring down the 2. Bring it all the way down. Multiply, right? 2 times 1 is 2. Add. Negative 5 plus 2 is negative 3. Multiply. Negative 3 times 1 is a negative 3. Add. 0 plus negative 3 is a negative 3. Multiply. Negative 3 times 1 is negative 3. Add. 4 plus negative 3 is a 1. Multiply. 1 times 1 is 1. Add, and I get a negative 3. Okay, so it's not a factor because that is not 0. I do know that. But the answer is this. It has to be 1 less power. 1. We bring the x's back. The x's were invisible, but we're going to bring it back as 1 less power, so it's a 2x cubed minus 3x squared minus 3x plus 1, and then my remainder goes plus a negative 3 over what I really divided by. What I really divided by invisibly was an x minus 1. Is it a factor? No. Okay, so here is my answer. Is it a factor? No, because the remainder is not 0. No, remainder is not 0. There's my reason, okay? Okay, is it a factor? No, the remainder is negative 3. It's not 0, so it's not a factor, okay? All right, so that's pretty much it. There might be a few other little things in it, but we'll just take this test and do our best, okay? So I'll see you tomorrow. Stop.